Hello and Assalamualaikum. Greeting towards fellow member of Polytechnic Sultan Salahuddin Abdul Aziz Shah, and especially towards Puan Aizam Atan. So today we will present about topic 2.0, which is differentiation in engineering mathematics 2. There are currently 4 group members in my group. I will start with myself, with Muhammad Ahmad Firdaus bin Ibrahim 08DPB22F2018. Next we have Hairul Hanafi bin Japri 08DPB22F2026. Next we have Muhammad Adam bin Arif 08DPB22F2006. And lastly we have Aiman Hazim bin Zuhaidi 08DKM22F2009. For forward table of content, first, we will have introduction of differentiation. Second, introduction of rate of change. Third, question 1, stationary point. Fourth, answer for question 1. Fifth, question 2, rate of change. Sixth, answer for question 2. And lastly, we will have the conclusion.
Introduction of differentiation. Differentiation in mathematics process of finding the derivative of rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of the differentiation can be carried out by pure algebraic manipulation using 3 basic derivatives, forms of operation, and a knowledge of how manipulate function. Application of differentiation. Stationary point. A stationary point of function is a point where a derivative of a function is equal to 0 and can be a minimum, maximum, or point of inflection. Application of differentiation. To determine if the stationary point is minimum, maximum, or a point of inflection, we must apply second order of derivative.
Question and answer for stationary point. Example, y equal to 9 plus 6x power 2 minus x power 3. Stationary point is dy over dx equal to 0. 12x minus 3 power 2 equal to 0. 4x 3 minus x equal to 0. X equal to 0. X2 is 3. When x 0, y 3. When x 3, y 12. Stationary point is 0, 3, and 3, 12. Maximum and minimum point. Determining the type of stationary point. D power 2y over dx power 2 equal to 12 minus 6x. When x1 equal to 0, d power 2y over dx power 2 equal to 12. Yeah, 0, 2 is minimum point. When x2 is 3, d power 2y over dx power 2 equal to minus 6. There, 3, 12 is maximum point. Rate of change. The derivative of the function y equal to f same to x, y equal to f. Measure the instantaneous rate of change of the output variable with respect to the input variable.
Okay, I will continue the slide. Okay. Question for rate of change. Suppose the rate of a square is increasing at a constant rate of 2 meters per second. Find the area's rate of change in terms of the square's perimeter. This is the answer. Okay, the next step is solving step. Since the question is asking for the rate of change in terms of the perimeter, write the formula for the perimeter of the square and differentiate it with respect to time. B equal to 4s dp over dt equal 4 ds over dt. The question asks in terms of the perimeter, isolate the term s by dividing 4 on both sides. S equal to P over 4. Write the given trait in mathematical terms and substitute this value into dp over dt. ds over dt equal to dp over dt equal 4 ds over dt equal 4 times 2. The answer is 8. Write the area of the square and substitute the side. A equal s power 2 equal p over 4 power 2. The answer is p power 4 and p power 2 over 16. Since the area is changing with time, take the derivative of the area with respect to time. Okay, like dA over dt equal p over 8 times dp over dt. Substitute the value of dp over dt, dA over dt equal p over 8 times 8. The answer is p.
Alright, and lastly, we will move to the conclusion. So, I have included 5 conclusions in this video. The first one is, by learning this topic, student can solve the stationary point question using the guide given such as been explained in video. Second, knowing more about differentiation. And third, learn about maximum, minimum, and inflection point. Fourth, sketch a maximum, minimum, or inflection graph. And lastly, solve rate of change question using formula provided. Thank you.